Alright guys, today we're going to learn about Riemann Sums. That is the spelling. I looked it up right before this lesson. I did not want to spell that wrong on Candy Camera. What's that?
Two N's or one M?
Two N's, and one M. There are two N's and one M. Alright, so Riemann Sums, guys, and we're going to use Riemann Sums to approximate area under curves.
Today's the 20th.
Today's the 19th.
Yeah.
All right, so all a Riemann sum basically is a bunch of rectangles which we add together to approximate an area under the curve. What do I mean by that? If I got some graph here. Just some parabola. And let's say I wanted to approximate the area from here, and this is going to be A, well it's clearly 0, to B, right? And we're going to approximate it using Riemann sums. Basically, what we're going to do is, well, let me look at this. First, you can see what the area is. This right here is the area, right? That we want to figure out. We want to figure out what that area is. What we're going to do is we're going to draw rectangles to approximate it. So the first thing, what I'm going to draw right here is actually a left Riemann sum. So it's going to go like this, here, and then here.
Are those rectangles going over your curve?
They are going over my curve. Very good point. So this right here is called a left-hand Riemann sum, and I'll write this down. But that's because it uses the left point of my rectangle. So we could figure out the area of all these rectangles, right, guys? Because what's the area of a rectangle, Pete?
Area of rectangle is length times width.
Length times width, right? So if we did the length times the width, or the height, right? Length times the height of each of these rectangles, this one, this one, this one, and we added it together, we get a decent approximation for the area under this curve. Does that make sense, guys? As I use more rectangles, my approximation would become what?
More exact.
More exact. Dan, you are amazing. It would become more exact. And this approximation, is this an over approximation or an under approximation?
Over.
Over. Perfect. All right. Let me do these. I'm going to actually do a right-hand Riemann sum. I'm going to show it to you graphically. And I'm going to split it into the 3 subdivisions again. What I do is I draw from the right point right up to where I hit. And so the right point, I draw right up to where I hit. I bring that over. Right up to where I hit. Right up to where I hit. This would be a right-hand Riemann sum because it uses the right side to see where it hits the function. Now, is this an over approximation or an under approximation?
Under.
Under, very straightforward, right? I love when you get asked AP problems like that. So, let's actually do it now. Let's do a Riemann sum. Let's look at the graph of, say, hope this is the right one, x squared, y equals x squared. And let's look at it over the interval 0 to 1. I'm going to say this is 0, this is going to be 1, this is going to be 1. Here's my parabola, goes through here, boom, boom. Okay, now what I want to do, guys, is I want to approximate the area under this curve, and I want to do it using a left-hand Riemann sum. So, how do I do it? And I want it to have, say, 4 subdivisions. So let's write this down. Left Riemann sum. You guys are so quiet today. That's good. Thanks, Jeff. Left-hand Riemann sum with 4 subdivisions, okay? Now, let's draw this out graphically. Actually, if I had done 5 subdivisions, it'd make my graph really nice.
Yes, it is.
I'm so gonna do 5 subdivisions. Sorry. Because
I don't have graphic.
I have a grid right here. So here we go, let's do this. Here's, what's the width? I'll call this the height and this the width. What's the width of each of my rectangles if I have 5 subdivisions? No, because I actually labeled this 1 and this is 0. It's 0.2, right? It's 1 divided by 5. And we'll summarize all this later. But 5 subdivisions, so the width of my first one would be 0.2. And actually, let me draw it before I go back and forth. I'm going to actually draw these rectangles. So here's my first rectangle. Since it's a left, how high is this rectangle?
Huh?
How high is this rectangle?
What do you mean? 1?
This rectangle right here, what's its height? 0. Who said that?
I'm so lost.
Come on, a nice job.
Why is it 0?
Because we're going to use the left point, but the value of x squared at 0 is 0. So it doesn't have any height to it. Okay?
Okay.
And let me comment here. This right here is y equals x squared. So if I drew a rectangle with a width of 0.2, but the left point goes up to where it touches x squared, well, it's already touching x squared right off the bat. So it doesn't have any height.
So
Let me draw some more.
area, right?
Why?
So would it
So
not
I
have
just
an
drew a
area
line,
to-
Why are
basically.
you drawing a rectangle with no height?
Would that make it a rectangle?
So it's not even a rectangle. It's nothing. It's nothing.
So why are you doing that?
Yeah, so why is it even?
So is that
Why
like?
is one side
How is that relevant to a solving yourself?
Whoa.
You guys will see in a second. Bear with me. Bear with me. So now, let me just draw all these rectangles. Here's our left Riemann Sum.
Let's find the area of each one.
And then here's this one.
No, that's a little bit.
Here's this one. Does that make sense now, Christian?
And then they're each one
Okay.
have-
So here's our left Riemann Sum. What I do is each of these rectangles has a width of 0.2. And I just take the left point and I draw it up to where it hits the function, right? So I take this, I see where does it hit the function, and then I draw it over. Does that sort of make sense?
I guess, yeah.
So if you start it,
Yeah, done.
if you do it the other way, we start from the top. Would each of them go down, Wiley?
Do it the other way, where I start from the top. Yeah. So if I start from the right, you mean? Or if I start from over on this side? What are you
Well, I
trying
mean,
to say?
like if you had an over approximation.
Yeah. A right-hand sum would be an over approximation. I'll show you that in a second.
Okay.
Okay. So let's now find the area of all these rectangles added together, okay? So let's do it. So the first one has a width of 0.2, they all do, but whatever, times f of 0, and this is my f of x. And so what is f of 0, Brianna? 0. Cool. Now, the next one right here, what's its width, Peter?
0.2.
0.2, they all have a width of 0.2. Width of 0.2, and what's my f of?
F1.
Is that 2?
Wait,
1/5.
sorry.
It would be 1/5 because right here we're actually at 1/5. Does that sort of make sense, guys?
Yeah.
And then, does that make sense?
Yeah.
Okay, so f of 1/5 plus, let's do this next one, width of 0.2 times f of what? 2/5, awesome.
How's it 1/5?
Because
So
he's going by the x value, he's not going by
the x value right here, yeah, I haven't calculated what the y value is.
We need the
Oh.
summation for this.
So it's going to be f of 0, f of 1/5, f of 2/5, f of, and f of. I'm not going to use the 5/5 because we're only using, this is our height, right? So we want the y value when x is 4/5. So we're going to do the height times the width. The width is 0.2. Let me write this out, then we'll talk about it. So 0.2, f of 3/5 plus 0.2, f of 4/5. Perfect amount of space, Bree. Good call with 5 subdivisions.
So
All right.
Is this why you taught us summation?
Yeah, you can do this with summation very fast. Exactly. Exactly. We probably won't really though, but